Everyone, I'm going to discuss on how we can create a large complex graph without any coding knowledge. Hence, we can create a big or massive graph with a single price. So I hope this sounds very interesting. It will definitely save your time, energy and effort. So, so in this discussion, let me tell you how we can create a large graph, a complex graph that can be exported into TikZ format. This TikZ is a graphic package. It is a powerful graphic package in LaTeX. So using TikZ, we can create very high quality graph in LaTeX document. With the help of one simple application that we are developing, you will be able to create a beautiful graph in LaTeX without writing a single code. That too within seconds, very fast. So you can instantly create a beautiful LaTeX graph with a single press. So that is very much possible with our simple application that we are developing. Okay, so before going into the details or demonstrations, I will show you what is, let me discuss what is a graph. What is graph in general? So graph means I'm not talking about the graph function graph. So I'm talking about the graph of graph theory. So we sometimes call a graph as a network. So what are the vertices? Vertices could be the collection of any objects, any entities, and edges could be the connection between any two objects, any two nodes. So these objects are called nodes. So this is graph. Okay, so this, see just example in this image. This is a general graph. This is a demonstration of a graph. So these dots, these are called nodes. These are called nodes. These are called nodes. Okay, so there is a connection between any of the nodes, means these two nodes or these two entities are connected in some ways. There is some interaction between these two nodes. So uh, this interaction or this connection between the nodes are called edges. Okay, so the edges could be directed or undirected. So in the physical world, you will see different kinds of graph that exist in the physical world. So any kind of physical relationship or interaction in this physical world can be modeled as a graph. For example, social network or your Facebook can be modeled as a graph. Say for example, these two are related, they have a connection. That means that these two guys are related. So maybe they are classmates. So these two guys may be classmates. Okay, so they are related. Likewise, these two are also related. So there's a connection between these two guys. Maybe they work in the same office, they work in the same place, so they are connected. Like any kind of relationship in this physical world can be modeled as a graph. Even just you think of your brain, we can think of a brain as a graph. Because in a brain, there are millions and millions of neurons or brain regions, and each neuron is connected by synaptic connections. There's a connection can be called as, suppose these dots are neurons, and this connection is supposed synaptic connections through which the one neuron interact with another neuron. So these connections can be called as an edge, and these brain regions or these neurons can be called as graph nodes, or it is graph buttocks. Okay, so the whole brain structure can be considered as graph, and we can give some value to the edges or connections. When some values are assigned to the edge, then that edge are called labeled edge. We call as a labeled edge. So in this example, these numbers can be some can signify the flow of signal from one neuron to another neuron through synaptic connections. So some signal may be weak or some signal may be strong. Likewise, will get different values or different weight for different synaptic connections. So this is just an example of network structure in a biological or physical world. This was just an example. Okay, now I'm going to talk about our applications, our if using this if how we can create a beautiful graph with a single press. As I said, with a single press, no need to write anything manually. We have to just give a algebraic expression. So it is very interesting. You will find it very interesting that how we can create a beautiful graph with simple algebraic expressions and simple algebraic operations. Okay, so let me tell you what is this star. This star in terms of algebra will be multiplication. In terms of graph theory, it will be graph join. Okay, you just see what is graph join. And plus operation, and plus operation in terms of algebra will be plus only, it will be a binary operation, a plus only addition. And in terms of graph theory, it will be called graph union. So you also see what is graph union. So these are two very simple examples, very simple definitions of graph theory term, graph union and graph join. So for the simplicity, for the ease of notation, I have just used graph union as a plus and graph join as star, uh, analogous to graph union and join respectively. Okay, so the specialty of this application is that we can use the range. So we don't need to input all the vertices manually. We can just use three dots like this range. That means it shows that the number is from 1 to 20, 1 to 20. Okay, and hello, this is just a hello, any string. We can use any strings as a instead of hello we can write any letter, any number, any character. Okay, so here in this expression you see that hello is multiplied to 1 2 3 dot 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 20. So hello is multiplied with every number inside the parenthesis. Okay, so in terms of a graph, hello is connected to 1, hello is connected to 2, hello is connected to dot 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 up to hello is connected to 20. So when you press the graph, you will get the graph like that only. Okay, I have pressed the graph and this you got the graph like this. Hello is connected to 1, hello is connected to 2, and hello is connected to every other vertices. So there is no connection between other vertices. Say for example, there's no connection between 1 2 2 3 and so on, because in this expression there is no star operation between other vertices. So star operation gives edge in this case. Okay, just remember. So if you increase the number, to suppose 100, you will get a bigger graph. You will get a bigger graph. You can create a bigger graph in within no time. Okay, so you can decrease the, you can adjust this size of the edge and vertices, and you can give a different layout and settings to look the graph in different ways. Okay, so let me give another spring view. Spring view is it will give you a nice view. This is a graph. Okay, so if you want to give some colors to some, nodes, suppose I want to color 1 to 5, suppose red, 1 to 5 suppose red, then 1 comma dot 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 3 times dot comma 5 and comma, suppose I want to give red color. Okay, red color. So you just press the graph So this kind of things, so you get red colors. So likewise you can give different colors to any nodes as you like. Okay, or you can also hide some vertex labels. Yes, suppose I want to hide 6 to 6 comma dot 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 3 times dot 6 to 10, suppose I want to hide. Then you have to write whatever the vertices you want to hide in this box, hide label for nodes, no? So you write here, yeah, and press the graph, press draw, the label will be hidden. So hidden, no? So this way. So now I will just change this graph to 20, just keep it 20, and let us keep auto. Okay, so you see red, and some nodes have been some level of some nodes have been hidden. Okay, I will decrease the size of the node. So if you want to give some edge labels, suppose I want to give some name to this edge, suppose hello n1, you can give the edge label. For example, I want to write hello and hello n1. Suppose I want to write GTE. Okay, what you get, just see. Now this edge, this particular edge is now labeled GE, so it is labeled with GET. So we can give the label as any character. B plus suppose B square. Now, so this is I have written in LaTeX mode. So this edge hello one will be given this labeling. I just pressed, so I have given this label to this particular edge. Okay, just I will show you another graph, this graph. Okay, this will give you a tree. This is a tree. Okay, different kinds of graph you can draw with a single press using range. It's very simple. So without using range also you can, so you can, if you want to create a complete graph, then you press 1 2 star 1 2 3 3 dots star, and if you want to give 50 nodes, 50, then press a graph, then press, you get this kind of graphs. Within no time you will create a graph. This is just an example. Okay, so we'll give back this. So let's draw this graph. Okay, if you want to put the particular nodes to a particular position, then you can activate this first line, activate manual layout editor. So you can activate, just check the box, and you press draw graph. So it is not activated yet, so again draw, press 2 times, then it will get activated here. It will get activated. So once this custom layout is saved, you can scroll down to the bottom in the left side. You will see that you can just manually change the coordinate. You can manually change the coordinate so that the position of the particular nodes you wish to change can be done here. Okay, so if I want to change the position of yellow, so x coordinate, suppose I want to change, then I want to change the x coordinate here, suppose 2, okay, suppose 1 suppose, then what I get, let us see. So it is moved to left side, because Yeah, like this. So we can change the position, we can change the position of the nodes by giving different values to x and y coordinate. So we can do as we wish. Okay, for now I will not, I will uncheck this. I will keep this only. Now you can export the created graph. You can export the created graph in Gephi, Cytoscape, or HList. So these will be useful for graph analysis. So if you want to do the graph analysis, you can export into this. You press any of this box and you will be able to download. Okay, and for now I want to export into LaTeX. Okay, because I'm interested in creating graph in LaTeX, but writing the graph code directly in LaTeX is a very tedious, and it's a very time taking, it's a error prone. So if it's a very tedious job directly working in the LaTeX or TikZ. So you just put a simple expression in this application. You will get a graph, beautiful graph. And if you want to transfer the graph into LaTeX document, you can also directly download as a PNG file, and you can just insert into your LaTeX documents. That is one way you can do. Or if you want to directly copy the LaTeX code, you can copy, you can press here and download it. Okay, I have already downloaded and I'm working on the overlay project. I will show you overlay project where I have downloaded. You will get the same graph as it appears in the application. So you will get this kind of same graph you will find. Now press here. So you will get this kind of graph in the LaTeX. So it is a very high quality image. So as I said, LaTeX gives one of the best quality graph, or one of the best quality image for publication. So this way you can easily create. So this is the equivalent LaTeX code for the graph. In our application, we have a very simple line. We have a very simple expression. This expression, you know, this expression, this very simple expression. But in LaTeX, we have a we have several lines of LaTeX code. So it will be very time consuming. It will take a lot of time. So if you just create a graph in our application, any kind of graph you can create here in our application and export it into TikZ format, and copy and paste it to your LaTeX document, and just compile. You will get a beautiful graph as you wish to see. Okay, the same structures, you'll be able to create the same orientation, the same graph that appears in the F. Okay, so this is one of the best way to save the time and energy in save the time and energy you would have been putting to manually write LaTeX code. So this is one of the special advantage of our applications. Okay, there are many other advantage of or usefulness of this application, so I will not be able to discuss now, and maybe I will discuss in the next discussion. Okay, so you can see the details of this application from app details and user manual. So if you go through this script, you will be able to understand how our application is working, how this F is working, how it will be useful for you. So I know that this will be very useful for, especially for the researchers who are writing the articles in LaTeX and who are doing research in graph theory. So maybe you have, sometimes you may have to draw a graph, sometimes you have to draw a very large graph. Then you want to save the time in energy in creating a graph, then you can use this simple application. So this is one direct application of direct benefit of this, the usage of this application, this f. Okay, so thank you so much.